Okay, so again, we're on page 15 of the notes. How tall is Harold? So I'll read the word problem, but we're gonna filter out stuff that's completely useless or pointless. So, oh, laptop. Can we lower laptops? We don't need laptops open right now. Yeah, just for until I finish the lesson. Thanks. So Jamal and Dina were still eating lunch as they came to Algebra 2 class. Someone left the book on the floor. They both tripped. As they hit the floor, the food they were carrying went flying across the room directly towards Harold, who's showing off his latest dance moves. Okay, that's noise. I mean, yes, whatever. They're trying to be funny. Okay, whatever. I'm gonna get rid of it. Yeah, it's just CPM gets really corny. As Jamal and Dina watching horror, Jamal's cupcake and Dina sandwich spelled right on top of his head. Yeah. Well, no, this is Harold. Yeah, no. Jamal's more Middle Eastern. I get that. Don't worry. I understand it. Well, or it could be African American name. I don't know. It could be a lot of different names. No, I have an uncle named Jamal. You know, it's an Arabic. You know, it's Arabic roots, right? Yeah, totally. Yeah, 100%.
I know that. I didn't know that. You didn't know that.
Okay.
Watch out. No.
Okay, guys, quiet, please. Thank you. All right. Well, here's the thing. When you throw something, or actually, Nathan can answer this question for us. When you kick a field goal, what kind of path is it on when you kick a field goal? Parabola. Thank you. So when you throw something, same thing. All right. Even if you throw it, guys, quiet. Even if you throw like a baseball or football really fast, it still has some sort of parabolic path to it because gravity. It's going to fall eventually, right? So anyway, this is the relevant information. 20 feet away. That's relevant, right? So Jamal's cupcake flew in a path that would have landed on the floor 20 feet away from him if it not hit Harold. So Harold's out of the way. It would land 20 feet away. So what I'm going to do is I'm going to make a coordinate plane. Guys, quiet, please. Thank you. So that right there is going to be Jamal's pathway, or we'll just call it the cupcake, right? That's the actual object that's being launched. And what's the x-intercept going to be, guys? Well, 0, and what's the other one? If it lands 20 feet away from him. 20, yeah, there you go. It's just that simple. So that's the pathway for the cupcake. Now I'll switch colors for the sandwich. It will land 24 feet away. Okay. So it'll be over here. And they're both also from the same distance, it looks like. All right. Actually, let me do this. Okay. Why did I make the blue a lower height? What's the height of the blue or the sandwich? Did it give us the height for the sandwich? 6 feet. Yes, the sandwich is 6 feet. How about the cupcake? 9 feet. Perfect. Excellent. So if I think about it, the vertex here has to be 9, 24. Sorry, 10, 9. My apologies. I have my numbers mixed up. I don't know why I said that. For the sandwich, what's halfway between 0 and 24? I know I didn't draw this accurately. 12. So that vertex would be 12, 6. Okay. So Aldina sandwich reached a height of 6 feet before hitting Harold. Okay. How tall is Harold? Okay. Oh, yes, go, Jaslyn. Yeah, no problem. All right. So as we take a closer look at this, so it said we'll land 24 feet away from her if not hit Harold. Again, Jamal's cupcake flew 9 feet high while the incidents reached a height of 9 feet. All right. So, and it looks like they both hit him. Right, okay, there we go. So what you want to do, oh, sorry, they both hit at the same time. There we go. All right. So what do you think I'm looking for? This problem. Point of intersection, exactly. Let me draw that blue curve. It's a little confusing. Let me draw a little better. Let me draw it more like this. There we go. So yes, you're looking for the point of intersection. Okay, so I'm going to abbreviate POI's point of intersection, okay? Well, don't I need equations to do this? how do I make the equations from this? We got to make two equations. So we'll start with the cupcake. How would I make an equation with cupcake, guys? You guys should know this. If you guys like Sour Patch Kids, I'll bring a whole bunch on Wednesday, by the way.
Oh, watch out.
I have a whole bunch in my house. I have a whole bunch in my house. You guys like Sour Patch Kids? All right. Okay, let's put them away. Thanks. All right. So, John, why don't you help us out? What's the vertex for the cupcake?
Okay.
Yeah, the black curve.
That's 10, 9.
Perfect. So we have x minus 10 squared plus 9. Perfect. But I don't know a yet, right? How am I going to solve for a? What can I use in the black curve to solve for a? These are not lines. You can use 0, 0 or 20, 0. It's up to you. You have to use a point on the curve that's already given to you, which are the x-intercepts. Remember, these are not lines, right? I know I said slope because you saw a coefficient. But remember, these are not lines. So it's just a concept we have to solve for. So I'm going to get rid of all this because I don't need this diagram anymore now. Now I know what I have to do. Solve for a point of intersection. So going down here, let's get this done. So 0 equals a, 0 minus 10 squared plus 9. Not to skip steps, very important. Negative 9 equals 100a. So the equation is this. Y equals negative 9 over 100. X minus 10 squared. And that's a lot of work. I apologize. But sometimes that's what we have to do. Does it make sense what I did? How I identify the vertex of the cupcake. Once plugging for h and k, then solve for a, I use an x-intercept, like 0, 0, for example. Plug it in for x and y respectively, solve for a, you have your equation, right? So that's done. Rinse and repeat for the sandwich. For the sandwich, so I'll use blue for that one. That's it. Y equals a. What's the vertex for the sandwich? What do we get for the vertex sandwich, guys? 12, 6. We're okay with that? All good? What are you playing for x and y? Again. You can do a 24, 0 or 0, 0. Either way is fine. Okay, girls, can you please stop? Thanks. So A is this. Geez, you need more space. Sorry about that. So Y equals okay. So that's that equation. You can reduce the fraction if you want. It's up to you. You can say negative 3 over 72. Actually, it's negative 1 over 24, I think. But regardless, you can leave it like that. At this point, what should I do now to solve for the point of intersection? Should I do this algebraically or should I use technology? Technology, thank you. In your case, you probably use a graphing calculator on a test, but for the homework, Desmos is totally fine. I don't know if I do equations quite like this on the calculator because it's a little crazy to graph these because you have to adjust the window. But we'll go to Desmos. Desmos is good. By the way, if this were an SAT style question, the SAT wouldn't have this corny story, but they totally could tell you got these two parabolic situations and asking you where they touch. They could totally ask that. That's 100% valid. That could be or viable. That could be asked. So I'm gonna do y equals. So you should be totally. So that's why you could use your laptops once I finish today's lesson. You could totally do that, right? Or if you're doing it at home, that's fine too. Have this. And I have this negative 6 out of 144 x minus 12 squared plus 6. Clearly, they touch at the origin. They touch right there, right? So how do I interpret that? Let me clear the screen. How do I interpret this answer, guys? 16.55, 172 is x. Y is 5.13, 674. By the way, Harold's kind of a short dude. So how would I interpret this? What does x represent, guys? Yes. So So basically, Harold was standing 16.5 feet away from both Jamal and Dina. So if I write this as if I summarize my solution, Harold is standing 16.5 feet away from both Jamal and Dina. Also, he is 5.14 feet tall. So he does get hit. So sorry. Well, we know he gets hit, obviously. There we go. And 0.14 feet multiplied by 12 inches. I don't know, that's like what? Yeah, like an inch and a half or something. So yeah, it's pretty short. Maybe this is middle school or something. I don't know. We're at a growth spurt. Or just short. Okay. So that's modeling, guys. That's what we're doing. We're trying to take the words and make equations from the words. And then how do we solve? Let's use technology to solve. Okay. So now this is not as exciting, just some equations, right? But do the same thing, right? Let y equal x minus 3 squared and y equal 2x minus 10. Or you could do this. Graph the original equation and find the x-intercept. You do that also. That's another way you could do it as well. It's up to you. If you do it this way, then you need the point of intersection. Why need the x-intercept? Great question, Aiden. Because when you solve this equation here, you're going to move all the terms to one side and see where it crosses the x-axis. When you move everything to one side, what do you have on the other side? 0, right? And so by letting y equal the equation if everything moves to one side, you're looking for x-intercepts. Or just find where they touch if you graph each side separately. It's up to you. No, because if it shows up graphically, it will be a real solution. If it shows up graphically, it's fine. So again, 2 methods. Maybe I want to write this down. It'll be calc. Because actually, something like this, we could do non, but I'm fine if you have a calculator. That's fine. Okay.
You just put it on one side.
Yeah. So guys, 2 methods. Graph each side of the equation and find point of intersection.
We just solve for the next.
Correct. Or graph the original equation as it looks and find the x-intercept.
Solve like 2 different things. Solve the point of intersection.
I'm just giving you 2 ways you could do it. It's up to you. Whatever way you're comfortable with. That's that. I'm just giving you options.
Yeah.
Correct. We'll see both ways. So you can see you get the same answer. So if I do the first way, let's see here. Y equals x minus 3 squared. Okay, simple. Y equals 2x minus 10. Oh, look at that. Did these even touch? They don't touch. So if I clear the screen for a moment, they don't touch. That's probably gonna be no solution. If I were to do this instead, x minus 3 squared equals 2x minus 10. Let me turn off the other 2. Oh, hold on a sec. Wait, why do I not? It's weird. No, we should still see the graph at least.
Huh.
That's bizarre. Oh, I think I know why. Yes, well, I mean, well, no, because things wouldn't go away. Hold on, let's try this here. Minus 2x plus 10 equals y. There we go. Okay, I should have done that instead. Yeah, that was actually weird. I don't know why that happened. Well, regardless, yes, you are right, Ellis, because there's no solution. We didn't see anything, but it still is a little weird to me. But you can look at, yes, because it doesn't equal 0, right? You're 100% correct. But if you do this, does this touch the x-axis, guys? No, right? So what I would do is, going back to what I said earlier, let me rephrase that because I actually don't like how I said that second thing. Graph the original equation by moving all terms to one side and setting it equal to y. Let me rephrase that. My apologies. That's what I really should have said. That's what I meant to say. That's what I wanted you guys to do. So either way, you get the same thing. If you did it algebraically and did the quad form, you would get a negative underneath the radical in the quad form. That'd also be a problem too. So that's no solution. So part A, no solution because no point of intersection or no x-intercept. Okay, let's do this again for part B. I'll do it the first method. Lincoln, go ahead.
It, like I can factor it. So if you can't factor it,
Not necessarily true. It's quad form or completing a square. If you do quad form and you have a negative underneath the radical, that's no solution. Because you can still get a solution if it's positive x-intercepts. That still could happen. Or sorry, if you have a positive value underneath the radical in quad form, it still has solutions. It's not because it can't be factored, it's because the quad form doesn't work. That's what's happening. All right, let's look at part B. Not necessarily. It's just gonna be a nasty number. It just means your answer is gonna be nasty. That's all. If it does work. Okay, so part B. Absolute value. Let's turn this off. Close it. If you hit abs, that's absolute value. X minus 3. Next up is still 2x minus 10. And let's turn them on. Okay, these do touch. Clearly these touch. And where did they touch? 7,4. So yeah, ABS is where you get absolute value. And the graphing calculator, hit the math button first. Yeah, off to the left, and then it should be under num. Then hits, or if you hit alpha window, there's a drop-down menu or a pop-up menu, and it should show you abs there as well. Okay, x equals 7, that's the answer, guys. That's all it is. And it makes sense because 2 times 7 minus 10 is 4. Absolute 7 minus 3 is also 4. So it totally works. So all's good there. It was good, yes. No, use Desmos, 100%. Yeah. Yeah, this could be like, could also be a free response question. We may have to type in the answer, so multiple choice. That could happen too. That's a possibility. Great question. Actually, let's talk about part B algebraically, guys, because part A I know you guys can do. All right. Okay, guys, quiet, please. So you're gonna do this. Okay, Lois and Alexander, you guys gotta stop talking, please. Thank you. All right, all right. Okay, if you think about it, the inside here could equal the other side, right? But remember we talked about when there's a number, like say there's like 4, for example, right? X minus 3 equal 4 or x minus 3 equal negative 4. It's kind of the same thing. X minus 3 equals 2x minus 10. Or it could equal the negative counterpart of the right side, which is that. So if we solve each one, you get x equals 7. Here, I think you get something that's called an extraneous solution, which doesn't work. Nope. X equals 13. So x is 13/3. But from the graph, we don't see 13/3 working. And if I were to plug that into, the reason why is that if I were to plug 13/3 in the original equation, that'll be 26/3 minus 10, which is actually a negative number when you work it out. It'll actually be negative 4/3. If you plug this back into the original equation, the right side is negative. Aspects can never equal negative numbers. Aspects always have outputs that are positive. So that would provide a negative output, which is a problem for absolute value. That happens. It can happen. And graphically, it's confirmed because look at it. It only touches once, right? When I look at my graph, it doesn't cross at 13/3, which is 4 point something. It crosses at 7. So that's what we got. So, but you use Desmos for your homework, totally fine, or the graph calculator. Okay, last one, and you guys can start homework. Actually, can I have the Sour Patch?
Yeah, you will.
No, I hate them actually. I did that. My kids love them. I don't know why. And it turns my kids into terrorists because they're like all sugared up. I just cannot. That and screen time. Yeah. All right, guys. Hey Lincoln, since it gets a little distracting, have you do this next one here. All right. So, huh? I know, but he grabbed it, so he distracted me. All right. So, how would I make a equation for job A? Or what kind of function is it? Is it linear or exponential? Job A?
Wait, no.
Linear? How would you make the equation?
2,000
Okay, good. Keep going. Good.
times X.
Excellent. Very good. Okay, guys, let's take a step back. Make sure we understand what we just did. All right. So, okay, guys, quiet, please. Thank you. So job A has to be linear because you start with 2 grand and every year you're making a $3,000 increase, a flat increase every year. It's not a great way of having a job because you should have a percentage. So negotiate that when you get on the real world. Most places do percentages anyway, so don't think you have to worry about that. But yeah, that's job A. Now job B is exponential, right? Because you start at 36, you start with less money, but every year you apply a percentage. John, can you get back?
Wait, Candy, well,
Okay.
in the bathroom, you ate it all. It's tough.
Okay, took. Yeah, thank you. She is right. Yeah, John, you are. I would agree. I would. I got. I got. John, just give up. Just give up. Yeah. Okay. But or yeah, he had taken my candy. You can say that. John, I know a good grammar tutor if you need one. All right. Okay. All right, guys, quiet, please. Let me wrap up. We're at the home stretch here. Guys, quiet. Quiet, please. Thank you. All right. So let's understand. I need you guys to focus. Thank you. Job B. No, the job. Yeah. Well, actually, yeah, you're John B. Yeah. Okay. Well, hold on, guys. Quiet, please. Thank you. So, okay, I'm gonna wait till you guys are quiet so I can talk. Thank you. I appreciate it. All right. So, $36,000 for the job label is letter B. If you have a 11% increase, you got to multiply by 1.11 to get the next salary, and you got to keep multiply by 1.11 every year as your increase, right? So initially, B pays less than A. So under what conditions is A better? Under what conditions is B better? Use graphs, blah, blah, blah. So we'll just graph these and answer the last 2 questions, and then you guys can work on homework, right? All right. So Desmos is going to be, again, a good approach. And John, worry about, I'll get you Sour Patch. Don't worry, I have a whole bunch in my house. You're just relax. All right. Okay, so you got a line. And you got an exponential function as well. Oh, there we go. Okay. So it's kind of hard to graph this to see how it looks right now. So this is a good exercise in making a window. Actually, let's do this in the graphic calculator as well, because I want to, because you guys actually do need to know how to do this in graphic calculator appropriately. Before we do that, if you go to Desmos, go to the settings. Now, this is where I need you guys to really focus on what is happening realistically, right? Let's look at what X represents, let's look at what Y represents. Okay. X represents number of years, right? You guys quiet? Let's focus. Okay, X represents number of years. So what should be the minimum for X, you think? Should it be negative 2,000 or probably a more appropriate number?
One.
Probably 0 or 1. Yeah, like year 0, guy makes 52 grand, right? Or the other guy makes 36,000. And maybe you're doing this for 20 years, let's say. You know, if you've been working for 20 years. All right. And the step will make steps fine, whatever, 2 or 1. I don't really care. It's not worried about it, actually. Okay, Y. Y represents salary. Is the salary gonna be negative? No, right? We'll do 0. And probably you can make up to like 200 grand, let's say. Well, maybe too much. Let's do $100,000. Okay. So by doing that, I've now adjusted my window to see where they touch, right? So it's pretty clear red is job A, blue is job B. Where did they touch, guys? John, what year did they touch?
Uh, six, the 6,000 or 6 point?
6.6. Okay, 6.63 years, right? Okay. So 6.63 years where they touch. And the salary is going to be $71,876.17. Okay. So they're both making that amount when they finally meet up with the same salary. Okay. So when is job A better? Job A, you can write this anywhere in the notes, is better for the first 6.63 years. Job B is better when you have more experience. So if you're only gonna do this job for a few years and go to grad school or do something else, then take job A, right? It's better salary. But job B is better in the long term. So okay, we're good. We're good. Lois, are we good? All right. Okay. All right. Is there anything else we need to answer about this? How can you change problem slice so that job B is always a better choice? Let's look at part B. Let's answer it really quickly. What you could do to make job B always better is higher initial value. Job A, probably higher increase per year, maybe. But guys, quiet. All right, let's think about this. The exponential function, right, will go like this. The line does this. Okay, guys. Okay, John, do you want to leave? Seriously, guys, this is enough. This is the last time you guys are sitting this way. Really? Seriously? Okay. I'm trying to talk. You guys are joking around about Sour Patch. I'm trying to be nice to you guys and kind, but seriously, this is whole disrespectful. Wow. Now I can hear a pin drop. All right. Thank you. Let's think about it. Okay, job B. How would you make job B a better choice? Let's back up a little bit. Here, let me backtrack. Actually, let me go back to the graph. Sorry. Here we go. Okay, so look at job A. Job A is in blue. Is blue lower than red right now in the beginning? When does it surpass? When does the blue surpass the red? Okay, what can I do to the blue equation to make it higher than A all the time, or higher than the red equation all the time? What can I change in the second equation, the starting point? So what if I do like 54,000? Now it's always going to be better, right? Well, because initially it starts 54, and the other one's 52. Okay, so so going back to what I was saying earlier in the notes, right? What can you do to make job be always better choice? Go with a higher initial value. Okay, good. I'm glad you guys are paying attention. You guys are getting this. Cause I don't want you guys to like, oh, I didn't talk. Well, yeah, I totally talked. You guys were disrupting me. Higher initial value, right? Okay. Now, can job A always be better? I did insinuate, what if I did a higher annual increase, right? But that's not true though. Okay, let's go back to job B one more time. Let's drop it back to 36. All right. I could make this higher, may start at $100,000, but still the blue is going to surpass the red eventually, right? Or go back to 52. I can make this higher increase, like $10,000. That's fine. But does the blue eventually surpass the A? It will. What kind of function is a B? Hey, boys, can you please focus? What kind of function is B? Exponential is always going to pass linear, regardless of what you do. So answering the question, what can you do to what can you do to job A to make it better? You can't do anything. You can't. So that's why exponential is always better. So is it,
Wouldn't it be better if like if like they intersected at like a million years?
sure, ultimately, right. But ultimately, right. But B will always be higher because it's exponential. Exponential is always higher than linear. All right. Okay, we're good. All right. So guys, let's use our time. We have another what 25 minutes. So get a head start on your homework, get it done. If you have the other homework you have to do, totally do it. Pages 17, 18. I'll work in the answer key as well. I haven't made the answer key yet. I'll make it. And yeah, and then we'll still do some more word problems on Wednesday. And we got another lesson to do as well on Wednesday. So I'll stop. And we are doing a scene chart on Wednesday, guys. I think we need it. So